Unit 10.2 is areas of parallelograms, triangles, and rhombuses. Notice the first one, it wants it in square inches. There's no conversions. We're looking for area only. So I'm going to white this out so we can just kind of focus on the pictures. The formula for a parallelogram is base times height. You can go back and figure out how those were discovered if you want to go back and look at the beginning of this chapter. So the formula for area is base times height. Opposite sides of a parallelogram are equal. Our base is 13 inches. The height is straight down from top to bottom, 90 degrees. So the height is the 8 inches, not that other side over there. We're going to multiply, so we multiply the numbers. 13 times 8 is 104. You multiply the names, and you get a new name. And when you multiply with like bases, you add the exponents, so you get square inches. So it's 104 square inches. Any questions on number 1? Number 2, the formula for area of a parallelogram is base times height. So we get area equal base, which is 24. The whole base, 24. Opposite sides are equal, times the height. The 13 is not the height. The height is from the top straight down to the bottom, 90 degrees, perpendicular. Here's my height. I'm going to have to use this little right triangle to solve for my height. I know 2 sides. I'm looking for the third side, so I'm going to use c squared equal a squared plus b squared to find the missing height. The 13 is the hypotenuse c, so we get 13 squared equal one of the legs 5 squared plus the leg we're looking for, which is the height squared. We're going to do what we can to simplify, so we do the exponents. 13 squared is 169. 5 squared is 25. We've done all we can do to simplify. The variable is not on both sides, so now it's time to undo. We're going to get rid of the 25 that's added on before we get rid of the exponent. So we undo what's added on by subtraction. We get 144 is equal to the height square. We undo the square with the square root, and we get that the height is 12. So we have area is 1/2 base 24 times height, which we had to find 12. And so the area is the product of those, which is 288. Any questions on number 2? Okay. We'll make a little room for number 3. And we're going to write down our formula, area equal base times height. So we have area equal base. Opposite sides are equal. So the base is 18 times the height, which we don't know again. It's straight down 90. We're going to use the little green right triangle, but all we know is one side. We don't know any angles or anything, so that's not enough information to solve with. But we do know that this is a parallelogram, and opposite angles are equal, so that angle's 70. Now I'm going to extract that triangle. So we have that this is 8. We're looking for the height, and this angle is 74 degrees because opposite angles of a parallelogram are equal. So we're going to use a trigonometric ratio to find the height. We're first going to write down that acute angle 34 degrees. We're going to see how the sides are related to the angle. The 8 is the hypotenuse. In relationship to the 74, the height is the leg opposite. Leg opposite hypotenuse is the sine ratio. And sine says to put leg opposite, which is h, over hypotenuse, which is 8. And so we have a trigonometric ratio to find the height with. Now, again, we can cross multiply if we want. So there's no rounding, and we will have 8 sine 74 equal h. And then we can go to our calculator. 8 sine 74 7.6901, and I did have this rounded to 4 decimal places. I've got it on float 4 as we talked about before, and I just forgot what it was. 7.6901 is equal to the height. If you want to leave it exact, you can. If you want to round to 7.7, you can. If you want to round to 7.69, you can. I just made a mess. If you want to make a mess, we prefer not. But I guess you can as long as you clean it up. This is a fun one to fix. I wrote over whiteout, see, and then I erased, and it just kind of gets crazy when you write over whiteout and erase it. I knew better, I just forgot. So we get times the height. I'm just going to round it to 7.7. So there he is, 18 times 7.7. Or if it's still in the calculator, you can just leave the whole thing. Times, I'm getting forgetful, I apologize. 18. Where'd my calculator go? And here I really didn't even round it all, and then I made a mistake. This is getting ugly, isn't it? 2 times signs. Okay, 7.7 rounded. We'll just do that. Times 18. Enter, how about 138.6? Or somewhere close to that. Any questions on number 3? Knowing that some people are going to round a little different, some will round, some will leave it, I'm going to give you a little bit of discrepancy as long as I can see you're doing the work correctly. That's what I would do. Your teacher may specify how they want you to round as you solve, or whether they want you to round until the very end, or how many decimal places they want it accurate to without rounding as you go. But anyway, your teacher will specify accuracy. And if you use this in real life, the accuracy will be specified by the blueprints for whatever you're dealing with. Okay? Okay, that was parallelogram. Now we're going to have some triangles. We're finding area only. on number 1, we're just leaving the unit, no conversions. Formula for area of a triangle is 1/2 base times height. I tell people base is the bottom. The height is how tall it is from top straight down to bottom. So area equal 1/2 times the base, which was 6 millimeters, times the height, which was that straight down from top to bottom, 8 millimeters. A triangle is half of a rectangle or half of a parallelogram. So we're going to multiply the numbers. 1/2 times 6 is 3, times 8 is 24. And you multiply the names and you get a new name. When you multiply with like bases, you add the exponents. So we get millimeters square, 24 square millimeters. Okay? Okay? Now let's look at the next one. I'm gonna do something a little bit fancy with the next one here, just to kind of try to make a point. Okay? Now remember that the base has to be one of the sides. The only side we know is 13, so the base is 13. And the height is how tall it is when you set it on its bottom. That's what I tell people. So how do you find the height and the base? It's all kind of weird looking. Now, what I'm going to do, just so I can show you this, is I'm going to take a snapshot of this with the little snapshot tool. Well, that didn't do what I wanted it to. I wanted to take a picture with my snapshot tool. I'll do that here. All right, and then I'm going to stick that in a notebook file, which it's here. It's here. All right, so let's take a look at that. Now, I know that 13 is the bottom. I'm going to click on that, and it's going to let me spin that around. 13 is the side I knew. So I'm going to spin that around mentally, or since we have the technology, we're just going to bring it in here and spin it around with the technology. And so the base is the side of the triangle that we know. So my area is 1/2 times base times height. So area is 1/2 times the base, which is the side I know, which is 13. Now, if you want to find the height, you got to set it on its bottom, as I call it. And we just took a snapshot, spun it around, and set it on its bottom. The height is how tall it is from top to bottom, but that height may not even be in the triangle. Remember that an altitude is a segment from a vertex perpendicular to the line that contains the opposite side. If I go to the top of this triangle, here's my triangle. If I set it on its bottom, I'd really like for that to be straight, but we're going to have to deal with it, looks like. When I set it on its bottom, how tall it is straight down from the top to the line that contains the opposite side. So that right over there is the height, okay? All right. So the base is 13, and the height is, I think that's a 4 square root 3. I'll have to blow it up to find out, okay? I'll be back. There's a quick glimpse at the original. It's a 4 square root 3. I'm going to pause and be back again. So the height is 4 square root 3. So the area is half of 4, which is 2, times 13, which is 26 square root 3. Any questions on that? So remember, in an obtuse triangle, sometimes the altitude is not inside the triangle itself. The base of the triangle has to be a side of the triangle. If there's a side of the triangle you have to think about setting it on its bottom, that side and then the height is there straight down to the bottom or the line that contains the bottom. Okay? All right. Number 3. Number 3 is an isosceles triangle, so we think about the isosceles triangle theorem. First of all, if this is 13, then this over here is 13 because opposite sides are equal. We knew that because of the marks, you see. Okay? Now, so what we've got are the equal marks here and the perpendicular there. That's 2 out of the 4 things from the isosceles triangle theorem. So we can automatically conclude that the other 2 are true. So the isosceles triangle theorem says the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. Now, that being the case, if that whole base was 10, then if this piece is 5, then this piece is 5, we could extract one of those little right triangles, and what we have is the hypotenuse is 13, this leg is 5, and we're looking for the height of the triangle. The formula for every triangle is 1/2 base times height. It's throwing my stuff in different places than I'm trying to put it. 1/2 times base times height. That was funny. 1/2 base times height. So we get area is equal to 1/2 times base, which is 10 times the height, which we don't know. So we're going to use this right triangle over here to find the height. I'm going to redraw that. Give me a second. I'm just going to start over. So we're going to use this little right triangle here, extracted where you can see it better. Use the Pythagorean theorem to find the missing height so we can find the area. Okay? So we're going to take the hypotenuse, which is the one across from the right angle, C, which is 13 square, equal one leg, which is 5 square, plus the other leg, which is our height square. We're going to simplify by doing exponents. These two, not that one. We're going to have 169 is equal to 25 plus height square. We've done all we can do to simplify. There's not variables on both sides. So we're going to start undoing. We're going to undo addition by subtraction. We'll get 144 is equal to the height square. Get rid of the square with the square root. And we get that the height is 12. We put that in for height so that we can find area. So area is half of 10, which is 5 times 12, which is 60. Any questions on the areas of those 3 triangles? The base is the side of the triangle. The height is how tall it is if you set it on its base or set it on its bottom. Okay? All right. Theorem 10.4. is an area of a rhombus. The formula for every rhombus we discovered was 1/2 diagonal 1 times diagonal 2. So we're going to write down our formula. We have a rhombus. Area is 1/2 times diagonal 1 times diagonal 2. So we're going to have area equal 1/2 times. Now, the diagonals bisect each other, so if that's 24, the other little part's 24, so that whole diagonal is 48 inches. The diagonals bisect each other, so if that's 10, then that's 10, so that whole diagonal is 20. So we're going to get area equal. Half of 48 is 24. 24 times 20 is 480. Inches times inches. You add the exponents. Inches square are square inches. And we're going to leave it in that unit. Any questions there? Okay. Example 2 in a rhombus. We need to know the properties of a rhombus. The definition of a rhombus is that it's a quadrilateral with 4 equal sides. The properties of the diagonals are that the diagonals bisect each other. That's from all parallelograms. The diagonals are perpendicular. That's special for a rhombus. Each diagonal bisects a pair of opposite angles. That angle was 60, so both of these are 30. That's special for a rhombus. So special for a rhombus, all 4 sides are equal. The diagonals are perpendicular, and each diagonal bisects a pair of opposite angles. That means that that little triangle right there I'm going to have to draw it bigger, and my board is making little squiggly marks. This was a side 10. This angle was 30 degrees. That means that that angle is going to be 60 degrees. Now, we're looking for the area, and the area is 1/2 times diagonal 1 times diagonal 2. And we're on picture 2. I'm going to go ahead and erase picture 1 and 3 so we won't be thinking that we're solving that picture instead of the one we're on. Okay? So, we can't solve because we don't know either diagonal. We don't even know a piece of either diagonal. If we knew the pieces, we could double them. What we do know is one side of this triangle, we know it's a 30, 60, 90. So we're going to write down our 30, 60, 90 right triangle formulas, which are long leg equals short leg times the square root of 3, and hypotenuse is equal to short leg times 2. Now, what we know is the hypotenuse. So hypotenuse 10 equals short leg times 2. Undo multiplication by division, and we get short leg is equal to 5. Now, if that's 5, then the other piece is 5, which means the shorter diagonal is 10. Long leg equal the short leg we just found times square root 3. So this is 5 square root 3. So both of these are 5 square root 3 2 5 square root 3's, and you probably can't see that, but 2 5 square root 3's is 10 square root 3. So we have our diagonals, double the 5, 10, double the 5 square root 3, 10 square root 3. Now we multiply. Half of 10 is 5 times 10 is 50 of those little square root 3's for the area. Any questions on example 2 for the rhombus? Okay. Example 3. Got all kinds of stuff going on. We got all these area formulas. We got right triangle rules. We got properties of parallelograms, rectangles, rhombuses, and squares. Number 3, we want the area. The formula for area of a rhombus is 1/2 diagonal 1 times diagonal 2. So we're going to get area is equal to 1/2 times diagonal 1. If this is 6, the other is 6 because the diagonals bisect each other. So that diagonal is 12, but we're missing the second diagonal. We know that the diagonals of a rhombus are perpendicular, which makes 4 congruent right triangles. If we extract that one, we've got that then this is 10, that 6 got covered up, and this is a piece of the other diagonal, and we'll just call it B. We're going to use the Pythagorean theorem to solve. C squared equal A squared plus B squared. The C is the one across from the right angle, the hypotenuse 10, equal A, which is 6 squared, plus the one we didn't know, which we called B squared. I'm going to white out the bottom so we'll have room to work. So we're going to do anything we can to simplify. We can do exponents, and so we get 100 is equal to 36 plus B squared. We're going to start undoing now. We undo addition by subtraction, and we're going to have 64 equal B squared. We're going to undo the square with the square root, and we'll get B is equal to 8. Now, that's this, which is half of that diagonal. So the whole diagonal is 16, so the diagonals are 12 and 16. So we get area is equal to half of 12, which is 6 times 16, which is 96. So the area is 96 square units. Any questions on rhombuses? 1/2 diagonal 1 times diagonal 2. Okay? Heron's formula. Heron's formula is a formula that we can use to find the area of a triangle if we know all the sides and we don't know any angles. It's kind of a handy little formula. Comes from trigonometry. Again, we're kind of taking an ahead look at some trigonometry here. The semi-perimeter is half the perimeter. S is the variable that we give to semi-perimeter. So if you know all of the sides of a triangle, you can find the area using Heron's formula. Now, these are non-right triangles, which means you can't do some of those Pythagorean theorems and 30, 60, 90s and trig ratios. So Heron's formula says that the area is equal to the square root of the semi-perimeter minus semi-perimeter minus first side times semi-perimeter minus second side times semi-perimeter minus third side. Let's see how this works with this triangle here. The first thing we want to do is find semi-perimeter, S. Semi-perimeter S is equal to 1/2 the perimeter, and the perimeter is the distance around or the sum of the sides, which would be 7 inches plus 6 inches plus 5 inches. So semi-perimeter is 1/2 of 7 and 6 is 13 plus 5 is 18 inches. The name stays the same. Half of 18 is 9 inches, so the semi-perimeter is 9 inches. That's not the area, that's just semi-perimeter. So area equals square root of semi-perimeter 9 times semi-perimeter 9 minus first side 7 times semi-perimeter 9 minus second side 6 times semi-perimeter 9 minus third side 5. So area is equal to square root of semi-perimeter 9 times 9 minus 2 is 7 times 9 minus 6 is 3 times 9 minus 5 is 4. So area is square root of 9 times 2 times 3 times 4. Now, hopefully we know enough about radicals and square roots and breaking them down that if we see a perfect square like 4 and 9, that we know we can bring out their perfect square factors. 9 is 3 times 3, so you pop out a 3. 4 is 2 times 2, so you pop out a 2. That other 2 and 3 would be singles, so they would go back in. And then you would multiply, and we would get 6 square root 6 for the area. 6 square root 6 inches. Any questions on Heron's formula? So we have parallelograms, triangles, rhombuses, Heron's formula, and we'll throw in some word problems with some percentages in it into the daily work. This was kind of a long lesson, so I'm going to stop and make the daily work a separate recording.